Okay, so this video is on lesson 4.1, and we are studying the nth roots, which mostly includes square roots and cube roots, okay? So if you remember back from like middle school, whenever you take the square root of a number, you're looking for a number that is squared. So if you're going to take the square root of 9, then you know that 9 is 3 times 3, or 3 squared, so your answer would be 3. Now, likewise, if you have a cube root, what you're looking for is the number cubed that's equal to 8. So you know that 2 to the third power is equal to 8, so the cube root of that would just be 2. Okay. Now, we're not going to do a lot with fourth roots and fifth roots and whatever, but this is an example of a fourth root. Not a lot of people know this, but 3 to the power 4 is 81. So if you're going to take the fourth root of 81 and you know that 3 to the fourth power is 81, then the answer is going to be 3. So what we're going to do today is we're going to learn how to deal with exponents that are fractions. And you've not done this before. So this is straight out of your book. It looks a little bit scary, but what I'm going to do is I'm going to break it down into like 3 different parts, okay? So this graphic's a little bit nicer to look at. So I want everybody to focus on this section right here in this box. Okay, so here's what I want you to do. I want you to take your highlighter and I want you to highlight the denominator. So whenever you see a fraction exponent, you need to look at the denominator. So the denominator is special. What it is, it's the actual root or index of a radical. So when I say radical could mean a square root, it could be a cube root, or any root, but that's what a radical is. So on the left-hand side, we have a rational exponent. It just means it's an exponent that's a fraction. And on the right-hand side, we have a radical. Okay, so over here on the side of your notes, I want you to write x to the power of 1/2. So whenever you see anything to the power of fraction, don't be intimidated. It's like code. It's just like we talked about in behavior code. It's the same kind of code here. So we're going to highlight your denominator. You're going to focus on that. So there's another way you can write it. You can write it using a radical. And that radical is going to have an index right there. That index will be the same as your denominator. So in this case, you will have a little 2 here. Now, back when you were introduced to square roots, you didn't typically put the 2 in there, and you still don't need to put the 2 in there, but it's perfectly fine on your notes, okay? And then all you're going to do is you're going to put the x there. So x to the power 1/2 is the same thing as saying the square root of x. So let's try a to the power of 1/3. Now that looks like really intimidating, scary, or whatever, but you know the code. So if the denominator is 3, then you can immediately change its form to a cube root of a. The important thing is that your index or the root is going to be the same as the denominator in your fraction exponent. All right, we're going to go backwards. So let's say I'll start with the square root of y. If I don't want it to be the square root of y, I can write it as y to the power of 1/2. Now, I have a lot of students, when they're brand new, what they do is they say it's to the power of 2. That's not at all going to be the same. That's not right. So if there's a little 2 here, you have to write in the denominator. So it has to be 1/2, okay? One more. Let's say I've got cube root of z. So the cube root of z is going to wind up being z to the power of 1/3. Okay, so on to the next concept. We're going to take it and make it a little bit more difficult, and I know that looks like craziness, but all we're doing is we're creating just one extra element to the problem, okay? So I'm going to go over here to the side, and I want you to work out a few of these problems. So let's say I've got z to the power of 3/2. So what we're going to do is we're going to still highlight the little 2 here. That 2 goes in the same place right here. So that's still going to be a square root, okay? But the question is, what do I do about the 3? So I'm going to take that 3 and I'm going to write it one of 2 places. So the first place you can write it is with the z underneath your radical. So what that does is it prioritizes your exponent of 3. So you would go ahead and you would simplify z to the 3rd power, and then you would take the square root. The other way to write it is this way. You still do a square root. You still put z there, but you put the 3 on the outside. That's the only 2 ways that you can write it. That 3 is still going to be a power, and your 2 is still going to be the root. Okay? Okay, another example. Let's say I have m to the power of 5 over 4. What is the index or the root? 4. Okay, so I'm going to put 4th root of m, but where do I put the 5? That 5 is either going to go right here with the m, or I can put it on the outside of the root. They are going to give you the same results, okay? So now it's time to practice. Okay, so go ahead and try to write this one out using radicals. You can do it both ways if you want to. I'm going to pause the video. All right, so we know that 4 is going to be our index. I'm going to put the little 4th root there, and then I'm going to save the rest y to the 3rd. Or you can put 4th root of y, and then that's in parentheses to the power of 3. Same thing. All right, so here's what I want you to do. On your notes, I want you to go backwards and forwards. I didn't do one with the 8 to the power 2/3, so I'll just do that one with you right now. So the denominator is 3, so that means it's going to be the cube root of 8 squared. And you can put the square on the inside or the outside, doesn't matter. So I'm going to give you about a minute. So y'all pause the video if you're watching the video and fill it out. Okay, so I've got the top 4 right here filled out. So just take a second, pause it, and check your work. Okay, so take a second and look at these last 3 real quick and pause the video to check your work. So 2 whole years ago, you learned something called negative exponents. So whenever you have a base, in this case base A, and it has a negative exponent, what you can do is you can change the sign of the exponent. You cannot change the sign of the A. That's never going to happen. You can't make A all of a sudden negative A. A lot of people want that to be equal to negative A. It's not a multiplication problem, so it's not going to be that. Basically, what you do, the rule states that if this is written in such a way, it's going to be equal to 1 over the power of A to a positive 1, okay? So what I want you to do is I want you to think of a fraction. So the way I originally wrote it, it didn't look like a fraction, but you can easily put, a 1 underneath it, and it wouldn't change the value. So you see how the A is upstairs? It's in that numerator. So when you take that numerator, that A, and you move it downstairs, the only thing that it does is it changes the sign. All right, so likewise, let's do a different example. Let's say I started out in the denominator. So A is already in the denominator. It's downstairs. So if I wanted to change that to positive 1, what I would do is I would move it up. So I would write A to the power of positive 1. The A never changes. The only thing that changes is your exponent. The exponent will change from positive to negative or vice versa. So this is what you'll wind up with if it's already in the denominator, okay? Now, the reason why we're going over this today is because you have even more complicated negative exponents. Let's say you've got A to the power of negative 1/2. What you're going to have to do is you're going to have to change the 1/2 to a positive 1/2. All you have to do is write it in the denominator. Do you see that change right there? Now, do you guys know what A to the power 1/2 is? Yes, you know A to the power 1/2 is the square root of A. So what you'll do, especially in your Delta Math on your practice, it will ask you to go from the left all the way to the right. And it's going to get even more complicated than that. So if you see something that has a negative exponent, you're going to either move it up to the numerator or you move it down to the denominator. Let's practice on your boards. So let's say you've got 7 to the power of negative 1/2. All I want you to do is change the negative exponent to positive 1/2. That's all you've got to do on your board. So here's what you do. If you notice a 7, we're going to put it in the denominator. The only thing that changes is your sign. So that's going to be positive 1/2. And then the last step is for you to change that 7 to the power 1/2 to the square root of 7. So that's how you work that one out. Let's make it a little bit more difficult. Okay, try 1/8 to the power of negative 1/3. Just change the sign of the exponent. That's all you need to do right now. So since it's already in the denominator, you're going to move it up, and it's going to be 8 to the power 1/3. Now, I noticed that several of you put over 1. Do you have to put over 1 in this case? You don't have to. It's not wrong. It's just you don't need to do that. Now, how do you change that to a radical? So what root is it going to be? Be a third root of 8. Now, can we do the cube root of 8? What's the cube root of 8? It's 2. Yeah. So you can take something like this without a calculator, and you can wind up with an answer. So the last thing on page 1 is we've got to figure out the difference between when does something have a negative power and when it doesn't. So if you look at the top one, everything's in parentheses. So everything in this top one is going to have to move to the denominator. Now, if it starts in parentheses, keep it in parentheses. So that's going to be the power 1/2. And then you can go ahead and change it to 2x. Now, you can keep parentheses around it. It's not going to hurt anything, or you can drop it at that point. The bottom one, though, on the other hand, that is not everything to the power negative 1/2. The 2 has a positive 1 power. The 2 will not move with the x. Now, really listen to me. The 2 is not going to move with the x. The 2 is going to stay where it is. The x moves with the exponent, and your final answer is going to look like that. So there's a very big difference in problems that have parentheses and problems that don't have parentheses. Okay, so I'm going to show you how to use your calculator to find some of these rational exponents and radicals. So we're going to type in 9 to the power of 1/5. So you just hit 9, and then your power button, and that'll be 1/5, and then just hit enter. So it's going to give you a sometimes it gives you a decimal, sometimes it doesn't. So this is about 1.55. Okay, next one's 12 and 3/8. 12 to the power of 3/8. So it's about 2.54. So the last one is the fourth root of something. So unless you're doing a square root, you have to use like a special combination. So if you hit second and your power button, it has this like ANS that stands for answer. So you don't want to do that. You actually want to type in your root first. So in this problem, I want to do the fourth root. So you're going to type 4. Then you hit second, power button, and then it puts the 4 up there in the little root position. So I've got 7 to the power of 3. 7 power of 3, and I wound up 4.30. So just make sure that you type in that root first and then do your special key combination with that. So in this section, I am pulling directly from the 8th grade section in Delta Math. And yes, it's 8th grade, and a lot of times we pull from middle school math in Algebra 2, and that's normal. It's okay. So we're going to enjoy it while we can. So let's say you've got 16x squared equals 9. So what I like to do is I like to divide my equations into a left and a right side. And I highlight, and you don't have to do that, but this is just like a me thing. I highlight what is squared. So what that does is it tells me that I need to get rid of the 16 because I don't care about anything on the right-hand side. I just focused on the variable that I'm trying to isolate. So I need to get rid of the 16. Now, the other day I had a student tell me that I needed to subtract 16. Is that right? Should I subtract 16? No. What we want to do is we want to divide. And the reason why we divide is because we look at the relationship between the 16 and the variable. 16 times x. So what we want to do is we want to do the inverse of that. So we're going to get x squared equals, and then, oh no, it's the dreaded fraction. We're going to be okay. So whenever you get the squared isolated, you're going to take the squared of both sides. Yes, have you done this before? Yes, you have. Now, the thing that people forget all the time is when you take the square root of both sides, you have to give a positive and a negative answer. So your final answer will be positive 3 and negative 3 over 4. Now, how did I do that so quickly without my calculator? Square root of 9 is 3. The square root of 16 is 4. So it's pretty easy. Now, I'm going to warn you, when you type this into Delta Math, though, you're going to have to hit the little plus sign on it. It says additional answer. And it'll create 2 separate boxes. And in the first box, you're going to put positive 3 over 4. And then the second box, you're going to put negative 3 over 4. So if you're solving a quadratic, so anything that's x squared, you'll have to do 2 boxes. Okay? Now, I'm going to skip everything else here, and I'm going to go all the way down to this one. So on your Delta Math, you have cubics as well. So I'm going to do what I did in the last one. I'm going to split it down the middle. I'm going to highlight this variable, and I'm going to only focus on the left side. I can get rid of the negative 6, or I can get rid of the positive 3. You have to go in a very specific order. When you're solving your equations, you want to go opposite order of operations. So you're going to do your adding and subtracting first. So I'm going to get rid of the plus 3. I'm going to subtract 3 from both sides. Then you want to get rid of the negative 6. To get rid of the negative 6, you want to divide both sides by negative 6. Now, I don't want you to panic, okay? It is a 3, but when you take the cube root, now notice I'm doing a different root this time because it's cubed. I'm going to take the cube root of both sides. You do not have to do a positive and a negative. You only have to do that if it's a square root. And if you can't simplify it, if it's not one of the popular 5, let's go ahead and write those. Did I have you write those down? Let's do that right now. And my computer just went crazy. So let's write these popular 5 down. So 1 to the 3rd power is 1, 2 to the 3rd is 8, 3 to the 3rd is 27, 4 to the 3rd is 64, and 5 to the 3rd is 125. If it's not going to be one of those 5, then I want you to leave your answer exactly just like that. So on your Delta Math, it'll have a cube root button to select, and then just put the cube root of 3, and then you're done. Okay, last one. I'm going to draw my line down through the middle of the equation sign. I'm going to highlight what I'm trying to isolate. I need to get rid of the negative 6. I need to get rid of the negative 4. I have to add or subtract first. So I'm going to add 4 to both sides. Now I can get rid of the negative 6. So I'm going to divide both sides by negative 6. And I think that's 14. And now all I have to do is get rid of the 3rd power. So I'm going to take the cube root of both sides. Is 14 one of the popular 5? It's not. So I cannot simplify the cube root of 14. So that's going to be my final answer. And that's it.